I'm Math Dad.
I'm Science Mom.
Today we're talking about fractions that can be written in different ways, but they're still the same number.
Ooh, equivalent fractions.
That's right. Let's dive in and see what that means. So to start off with, Science Mom, I want you to shade a square, but only half the square.
Okay, in 6 different ways.
And I want you to do it in 6 ways. Yep.
Now, if you downloaded our worksheet, which is in the description, you can do this as well. And you can probably do it a little neater than I'm doing it because you won't be rushing. So I can do diagonals, I can do halves, I could even do different halves.
Okay, let's see. Get creative, Science Mom.
Get creative?
Yeah.
Well, if I cut it into 4 equal pieces and then I shade 2 of those,
Oh.
that's half shaded.
I like
Or I could do it like this. My sides don't need to be touching, and that's the same as this one. Or maybe I could even get really crazy and do some sort of like a... maybe this isn't going to work. I had an idea. It went south. For my last one, I'm going to just be safe and go like that. Ta-da!
That does work, and I suppose that counts, even if it's not the prettiest drawing I've ever seen, Science Mom.
Thank you.
All right, so here's a common scenario we have at our house. So Andrew ate 4 out of the 8 slices of pizza, leaving not enough for poor Math Dad. So, but okay, the question is, what fraction of the pizza did he eat?
Well, we just need to color in 4 pieces. 1, 2, 3, 4. Let me get a darker color so we can see that a little bit better. A half a pizza.
4 out of 8 slices is the same as 1/2 of the pizza.
Ooh.
So 4 divided by 8, or 4/8, we've seen that's a fraction. And that fraction is the same as the fraction 1/2. The same number written 2 different ways. We call them equivalent fractions.
Nice.
And do you think you could find another equivalent fraction that's equivalent to those 2?
I think I can, because if I were to cut this pizza into 4 pieces instead of 8 pieces, and then if Andrew ate 2 pieces, that would be the same as, whoops.
You can do this, Science Mom. You can do it.
2/4.
Very nice. So I kind of like what you did there, Science Mom. So when we went from the fraction with the bigger numbers to the smaller numbers, that was like gluing the pieces together.
Ooh.
So we started with 4 slices on the right-hand side there, and you glued them together and said, that's just one big slice. And that made the left side one big slice, so there were just 2 slices. Or when you cut it into 4ths, that was kind of like gluing the pieces together. That instead of having 8 slices, then there were only 4 slices, and you were able to go from a fraction that involved bigger numbers to one that used smaller numbers. Now, which of those is the simplest?
This one, 1/2 is the simplest.
1/2 is the simplest. It has the smallest numbers, and typically that's going to be advantageous to make calculations easier. So we call that the simplest form, or the reduced form. But yeah, what fraction of the pizza did he eat? He ate half the pizza. I want you to write 5 fractions that are equal to 2/3, so equivalent fractions.
Ooh. So an easy way to do this, in my opinion, is to think of that pizza, but this time, instead of gluing pieces together, we're going to be breaking them apart. So here is 2/3 of a pizza, and now if I,
So that's 3 slices of a pizza, so each individual slice is 1/3 of the pizza.
Yeah, and if I shade it in like this, there we go. That's 2/3 of a pizza.
Good.
And now if I cut every one of those in half, 1, 2, 3, 4, 5, 6, I have 6 total pieces, and 4 of those are shaded.
So 4/6 is...
So I can say 2/3 equals 4/6 equals, well, I could just do the same thing again. I'm going to cut them in half again.
Oh.
So how many pieces do I have now?
So now you'd have 12.
12 pieces.
It almost looks like a clock, the way you've sliced it up here.
It just about does. And now I have 8 that have been sliced.
So 8/12 is
8 over
an
12?
equivalent fraction. Remember, 8 is what we call the numerator, 12 is the denominator.
That's right. And I've noticed that to get from 3 to 6, I just multiplied by 2. To get from 2 to 4, multiplied by 2. Because I was cutting these pieces in half, and I did the same thing here and here. I just multiplied by 2. So without even slicing my pizza, if I multiply 12 by 2, that's 24. 8 by 2, that's 16.
Outstanding.
That's another one.
16 divided by 24, or 16 24ths, is equivalent to 2/3. They're
Now I
equal.
have 4 fractions here, but to get my 5th one, I'm going to draw my pizza again, where I had 2/3 that was shaded. So this section right here is going to be my shaded section. But this time, instead of dividing each pie slice or each pizza slice in half, I'm going to divide them into thirds. So this one I cut into 3 pieces. This one I cut into 1, 2, 3 pieces. And then this one I cut into 3 pieces. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops.
9 total slices.
9 total slices, and 6 out of 9 are shaded.
And 6/9 is equivalent to 2/3. Those
So
numbers are equal.
These are all equivalent fractions.
You found 5 of them. Now, how many do you think there are?
Oh my goodness. A lot?
Infinitely many.
Infinitely many?
You could just keep slicing these smaller and smaller, and the proportions stay the same. So there are infinitely many ways of writing each number. It's kind of a weird thought. Our challenge here, Science Mom, is to write each fraction in simplest terms. So let me do a demo problem for us. 20 divided by 25. So we might think of that as a 25 slice pizza, but we're shading 20 of the 25 slices.
Someone was really hungry.
You know, gotta feed me better. But pizza's good. We all like pizza. All right, so we're gonna do that trick where we're gonna rewrite 20 by finding a factor pair, and then we're going to glue the slices together. So 20, what 2 numbers go into 20?
4 times 5 equals 20.
4 times 5, I like it. What about 25?
5 times 5 equals 25.
5 times 5. Okay, so now I'm going to cancel these 5s, and by canceling them, we're gluing them together in groups of 5.
So we're taking 5 slices and putting them together and saying this is now 1 slice.
That's right, because there were 4 groups of 5, so now there's just 4 shaded slices. And we had 25 originally, but we glued them together in groups of 5. That leaves 5 groups. So
I like it.
that would give us 4/5.
Ooh.
So 20 over 25 is the same as 4 over 5. And you might notice there are lots of different ways to say these fraction numbers. 4/5, 4 divided by 5, 4 over 5. Yep,
They all mean the same thing.
they do. All right, 24 divided by 30. We're going to simplify this one.
4 times 6 is 24.
4 times 6 is indeed 24. That was a good start.
And 3 times 10 equals 30.
And 3 times 10.
I don't see any numbers we can cross off.
Nope. So
What do we do?
we've got a couple of options. We could try to start over and look for another factor pair, and in all honesty, that's probably the fastest. However, let's press forward and see if something good happens, because these numbers can be broken down into smaller pieces, at least some of them. So for example, 4
2 times 2 equals 4.
is 2 times 2, and we're always using multiplication to break it up, not addition. All right, and what about 6?
2 times 3 equals 6.
Okay, 2 times 3. So all I've done is rewrite the numerator. I've replaced numbers with something equal to them. And on bottom, well, the 3 can't be broken up, but what about 10?
2 times 5 equals 10.
2 times 5. All right, so we can check our work and see that we've only replaced numbers with something exactly equal to them. And at this stage, are there some things that can cancel?
There definitely are. I see a 2 and I see a 3.
Okay, so the 2 will cancel, and you said the 3 will cancel, and it really didn't matter which 2 I canceled there. So essentially we were gluing them back together, those pizza slices, but on top, now, what's left? 2 times 2?
4.
4, and on bottom?
5.
So 5.
It's the same fraction. 4/5.
Oh, it is the same as the previous answer. That was coincidence, but kind of cool. So those are 20 over 25 and 24 over 30 are equivalent fractions as well. Real quick, what if I had canceled the entire bottom? 3 times 2 times 5. What if everything had canceled? What would be left over?
Whatever was in the top, just your numerator.
Right, but more importantly, on bottom, I'm trying to just emphasize that it's a number 1.
1.
It's not a 0. It's a 1. There's always a 1 left over when you divide a number by itself. So I just want to make sure we understand that. All right, then our last one here, 16 divided by 36.
16 is equal to 4 times 4.
4 times 4.
36 is equal to 6 times 6. But if I do that, I don't have a 4.
Aha. So we could write 6 times 6 and do it like this previous problem where we keep breaking them down. Or
I also know that 4 times 9 equals 36. And then
aha. So,
I have my 4s.
So with that choice, you thought about it a bit. You got the right factor pairs so that we have a common factor on top and bottom. The 4 shows up in both places. So we can cancel out the 4s, and that will leave us with 4/9. So those are the simplest terms for each of those fractions.
Very nice.
All right, we're going to use a picture to show whether 6/8 is the same as 9/12. I've got a typo there. Whoops.
Uh-oh.
That's okay. Will you forgive me?
I'll fix it for you. Ta-da!
Problem solved. That's why I keep Science Mom around. All right, so 6/8. If we want to draw this, and there are several ways of doing it. Actually, the shortest and easiest way I can think of doing this is to write each fraction in its simplest form first. So really quickly.
So instead of drawing a pizza and trying to divide it into 8 pieces, you're going to look at this and say, all right, 6 is equal to 2 times 3.
2 times 3. And
8 is equal to 2 times 4.
Aha. So the 2's would divide out, and we get 3/4. So 6/8 is equal to 3/4.
And it's a lot easier to draw 3/4 than to draw 6/8 when you're drawing a pizza.
It really is. And she knew I was going to draw the pizza. That there are other shapes, and they work well, like a square. But like we said, I'm hungry, so pizza it is. All right, so 3/4. So we might think, all right, I'm going to end up shading 1/4, 2/4, and 3/4. All right, but then I'm going to subdivide this shape into 6/8. So real quick, if I cut it into 8ths, boom.
That works. There are 6 out of the 8 shaded.
That's right. And I'm going to do the exact same picture again, but this time I'm going to cut it into how many pieces for the other fraction?
12.
12 total pieces, and that was because the fraction says 9/12, and the denominator, the 12, tells us how many pieces that would be. All right, so we slice there, slice here, and then we try to do each quadrant into thirds, and we may or may not succeed at that, but we try our best.
That was good.
All right, so just counting them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9/12. So all in all, we're able to conclude that 6/8 was equal to 9/12 because they both represent that same portion of the pizza. They both represent 3/4. All right, I have a riddle for you here, Science Mom. What begins with T, ends with T, and has T in it?
Tortellini starts with T and has a T in it, but it doesn't end with T.
That's true.
Tortellini. I don't know. What is it?
It's teapot.
Oh, teapot, because it has T inside the pot. Very nice.
That's right. So not the letter T, but rather
actual T.
Actual T. All right, it's time to take the pencil and do some problems here. I want you to write each fraction in simplest terms, and I want to remind you of a few things. Make sure you use the equal signs and that you're writing out true statements. So there are really only a few things we're allowed to do in math. You're allowed to add 0 to a number. You're allowed to multiply a number by 1. And you're allowed to replace an expression with something that's equal to it.
So this is why I can do this, because 12 equals, say, 2 times 6.
12 is 2 times 6. Yep. So you're replacing the 12 with something equal to it.
Right. Okay. And 32.
So is there a 2 or a 6 that would go into it? Because otherwise,
So 2 times 16
2 times 16 is 32.
is 32, but then I can get rid of the 2's, but then I still have 6 over 16, and then I can say, wait, those are divided by 2 as well.
Aha.
2 times 3 and 2 times 8. And then if I take out that second set of 2's, then I get 3/8.
Excellent work with your equal signs. It all reads like a beautiful sentence. This equals this, which equals this, which equals this. It's enough to make a math teacher cry. It's so beautiful.
All right, I'm ready for another one. 15 equals 3 times 5.
Good.
And that's a good factor pair for me to write because both of those are prime numbers. 24 equals 3 times 8.
Good.
Cross off my 3's and I'm left with 5/8.
Nicely done.
And then last but not least, 28 equals 4 times 7.
Good.
I had to think about that for a minute. I'm a little rusty with my multiplication, especially when I'm being filmed. And 48 is 4 times 12. And I can glue those slices together or cross off my 4's and I get 7/12.
I like it. So yeah, you took the 48 slices of pizza and we glued them together in groups of 4, and that left 12 groups of 4. 7 of those groups would have been shaded.
Excellent.
Right, I want you to use a picture to show whether 6/10 is the same as 4/6.
All right, so if I approach this by drawing pizza slices, I can cut a pizza in half and then divide this into 3 pieces and that into 3 pieces. That's 6 total pizza slices. 1, 2, 3, 4.
Okay.
There's 4/6. Now I can do the same thing with 10 pieces, but this is a little bit trickier. If I divide it in half, I have to divide each of these halves into 5 equal pieces.
That's right.
1, 2, 3, 4. That almost looks equal.
Are you one of those people that takes the pizza slicer and only cuts halfway through and then stops, Science Mom?
It's a little tricky.
It is.
And now let me...
And someone's going to get upset because you did. But my piece is smaller.
That's right. This is the piece of pie that everyone's going to want because it's a little bigger than the rest. But if we ignore that and shade these in, so we have 1, 2, 3, 4, 5, 6. Ooh, those look kind of close, but I do not think that they are the same. I think this one is a little bit bigger. But how can I know for sure? Well, I should reduce both of these.
We
right?
could reduce those 2 fractions. So let's get a little bit more confident. So one thing I like that you did, you started by just slicing it in half on both pizzas. So 1/2 got entirely shaded for both pizzas, but then 1 part out of 3 got shaded here,
Ooh.
and 1 part out of 5 got shaded here. So that right there tells us that they're not going to be equal. But go ahead and reduce each of these,
Yep,
because I like that strategy.
Yeah, they are not equal. This one is bigger. So this one is 4/6. And 4/6 is equal to 2 times 2 divided by 2 times 3. I can cross off the 2's. It's equal to 2/3.
Nice.
And then for this one up here, I have 6/10. 6 equals 2 times 3. 10 equals 2 times 5. Cross off the 2's, and I get 3/5.
And both of those fractions are in their simplest form, and since they're not equal to each other, that would also tell us that these 2 fractions are not equivalent.
Very nice.
A shout out to our patrons who made this video possible.
We could not do this without you. If you'd like to check out our Patreon page, go to patreon.com/sciencemom and join us.